Hello, my name is Stuart, and this is a demo of my EloDecider project. The motivation behind this project was I encountered the situation a couple times where a whole group of people needed to decide on some activities, and it turns out often that is a very computationally expensive combinatorics problem. So the first time we ran into this, three cousins were on a video chat trying to plan a vacation. People are posting links to different activities. Some of the activities basically overlap, the same kind of thing. Which outing, do we want to go on? This one has lunch, this one doesn't. This boat trip sees a waterfall, this other one doesn't. And over the course of 3 hours, we made some progress. The same problem you encounter when you're talking with your friends or coworkers trying to figure out where to go to lunch. A whole bunch of people are okay with Chinese food. One person just had Chinese food. You have to restart. And so the whole process of group decision making would be made easier if you knew exactly how much each person valued each item, and then when you decide on what kind of selection heuristic you want to use in selecting, or at least producing, a ranked list of how you value the items as a group becomes trivial. And it turns out that the hardest part of that is getting how much each person values each item, and that actually isn't all that hard. So I made the tool. Let's take a look. Here's some of the actual code. The first component here is the ELO comparer. And so what you're going to want to do is in the repo, in the adventures folder, you're going to want to create a new adventure. So I created an example here. And you can run this on either URLs or images. I'll open URLs. It is just a list of URLs. For images, it is just a directory of images. Why these two things? Well, I give the example right now of group decision making in terms of planning activities or meals. You could also have group decision making. I went on the vacation with my cousins. We all had a million pictures. How do we decide which pictures we like the most? It's the same question. So I made it so it could handle either of these two cases. All right, let's go through how this works. So we're going to want to run the ELO compare script. And the way that we do that is Python ELO comparer. All right, we need to put in our adventure name, which is example. Do we want to run this on images or URLs? I'll do URLs first. It's basically the same process with images, but I think the value is more apparent when we do it with URLs. And then what is my name? So you're going to need each person to go through this process. So I would go first. And what I did was that URL's text file contained a list of 5 Atlas Obscura destinations. And so this GUI opens, and we have 2, and we're basically swiping right or swiping left. What are we more interested in? So for me, choosing between these two, a murder well or a bookshop. Murder well sounds pretty cool. All right, so I like that one. And now with each click, we're updating the ELOs. Okay, murder well or tunnel number 3. This one looks like it's a little bit more of like urban exploring, so I'll click that one. All right, we have an art wall or a Theodore Roosevelt Museum art wall, bookshelf for the museum, and at the top we have a counter just telling us how many more iterations we have. If you're wondering how this is calculated, I actually have a comment in the code explaining it. It turns out unless you're going through very large numbers of items, actually you only need to do about two times. You only need to do a number of iterations equal to about 2 times your number of items to have pretty good convergence for the rankings. And so we're on our final iteration here, and that's it. That was only 5 items. I was talking, going slow the whole time. It took a couple seconds. You can have 30 URLs, 60 URLs, which if you're debating with friends takes forever, but clicking through them, like 120 clicks or 60 clicks, super quick. So that's where the efficiency of the project comes from. All right, so we did that, and then I would pass off the laptop to another friend, and they would do the same thing. All right. right, so adventure, example, URLs. This friend will be named Bob. And it's the same process. I just talked through it. So I'm just going to like swipe right, so to speak. I'm going to click on the right one for all of these just to generate some data. And these are browser windows. You can scroll, you can click in them if you want, but I don't really feel the need to do that. Perfect. All right, so you'll see we generated these two pickle files, example URLs Bob, example URLs Stuart, which basically contain the ELO rankings that we've generated. Now we're going to go on and we're going to run the ELO selector script. And basically this reads in our ELO rankings, applies our selection heuristic, and will show us how we've basically rated everything. So we're doing ELO selector. What's our adventure name? It is example. We're doing URLs. All right, which users do we want to consider? In theory, you might pass the laptop around to 5 people and only care what 3 of them think or something. So we'll just use everyone here. We want to see what Bob thinks and what I think. Now, what selection heuristic do we want? Min, average, or max? So the min selection heuristic is the one that I think people intuitively use the most often. In the lunch example, 5 friends want to go to lunch, 4 of them are okay with Chinese, 1 of them isn't. So you redecide as a group. That's the min heuristic. Like the person who rated an option with the lowest ELO, like that's the ELO you go with. You're trying to maximize that. Average is exactly what it sounds like, average, and then max, the way I would like describe that intuitively, is sort of how you value things if you were maybe going on a date with someone. So maybe you aren't that interested in going to the art museum, but the person you're on a date with is. And so you don't mind going because they'll be super happy. So the ELO for an activity would basically be the max of, all of the individual ratings. So we'll put in min here. And this is going to populate with what our options are. So it's saying our top collective choice is the mysterious bookshop, followed by that tunnel that we can urban explore, followed by the art wall, the Teddy Roosevelt Birthplace Museum, and the murder hole. And that is it. It'll wrap around, and we can close it. So hopefully, also this little text file gets generated where basically, if we wanted to look at those individually, it now has ranked them from top to bottom. Yeah, that is basically how it works. We can do that with images too. When you go through the images, it'll create a new directory with the images where they're renamed such that they appear in ranked order. So you can appreciate them as they were rated. And again, if this example seems like, oh, I don't get it, that was just 5 things, get a couple people with like 10 or more things, and all of a sudden, like this process becomes very complicated. So this is meant to, really parse things down and get to faster decision making. And I haven't used it yet, but I am really excited to. So maybe I'll update the README with a little comment for how well it was received. But that is it. Thanks a lot, and I hope you liked it. Bye-bye.